Okay, welcome back. Very cool little video there. We are now very excited to get going with our keynote speaker. For that, I'd like to welcome Lisa Callahan, Vice President and General Manager, Commercial Civil Space at our Day 3 sponsor, Lockheed Martin Corporation. Lisa, take it away.
Thank you, Jim, and thanks to AAS for 3 great days of programming and another successful symposium. Lockheed Martin is proud to be a sponsor. I'm pleased to join you today to introduce your keynote speaker. By now, this man needs no introduction, particularly in front of this crowd. So let me just share with you a recent success that Jim's had in his tenure as the administrator of NASA. Just last week, NASA's OSIRIS-REx spacecraft collected samples of the building blocks of our solar system from over 200 million miles away, a mission that Lockheed Martin is incredibly proud to have designed, built, and operated for NASA. You just saw a snippet of that in the video that played right before my introduction. That collection will enable a new generation of researchers to gain insight to how the organics of the water came to Earth, and insights on how our solar system was formed. And I think we will be joined this industry in part because we just wanted to contribute to the next giant leap in knowledge. Taking a piece of the asteroid Bennu was no small feat, and I'm incredibly proud of the entire OREX team. Jim, it meant a lot to the team that you personally called them that night to congratulate them on their successes, and it's a testament to the collaboration between NASA, industry, and academia, and what we can achieve as a team. In the next year, we'll see major components of the Artemis program come together for the first time at Kennedy Space Center, the foundation of a sustainable human lunar exploration. We're excited and ready to deliver the Orion Artemis 1 crew module in early December. Delivering the first woman and the next man to the surface of the moon is a national effort, and it requires innovative technologies, innovative approaches, and innovative partnerships. Now I'm excited to hear Administrator Bridenstine's thoughts on where we are going as a nation and a planet, and what that sustainable future in deep space might look like. Jim, over to you.
Well, thank you so much, Lisa, and thank you for highlighting OSIRIS-REx. Lockheed Martin, of course, was the lead contractor on that with the mission control facilities, and the University of Arizona was the principal investigator with their scientists. And you're absolutely right. When NASA teams with academia and industry, we really have the opportunity to achieve some magnificent things. And so we are so grateful for our partners, and we're so excited about what's coming next with OSIRIS-REx. I think a lot of people saw that when we touched down on Bennu, we actually went quite a bit deeper than we thought we were going to go, that we collected a lot more sample than we thought we were going to collect. And that's a good problem to have. But as we speak, that sample is being stowed for an eventual return. And I can't wait until 2023 when OSIRIS-REx drops off that sample, and we can see for the first time, the results of a United States asteroid return mission, which is going to be so exciting. And I remember when I was in the house, I had the opportunity to visit OSIRIS-REx face to face when I went out to the Space Symposium in Colorado and visited the Lockheed Martin facilities out there. And I remember thinking, wow, that thing's going to bring a part of an asteroid back, and I'm going to see it with my own eyes. So what an exciting time. I know 2020 has been a tough year for a lot of people. We've had some really amazing highlights in 2020. We talk about DM2 with Bob and Doug going to the International Space Station for the launching American astronauts on American rockets for the first time since 2011. We talk about launching Perseverance to Mars. Perseverance is now halfway to Mars, so we're very excited about that entry, descent, and landing in February. I'm even more excited about Ingenuity, the little helicopter that's going to fly from Perseverance. So many good things are happening. And what we're trying to do at NASA now is make sure that the programs that we're building for the long run are sustainable. When we got direction to go to the moon, it was not just go to the moon, it was go to the moon sustainably. In other words, stay at the moon. and to go with commercial partners and to go with international partners, to learn how to live and work on another world for long periods of time. And then take using the resources of that world, and then take all that knowledge onto Mars, because ultimately what we are going to do is send humans to Mars. That's the objective. Now, when we think about building this sustainable program, there's a lot of ways to think about sustainability, and a lot of people talk about technology and what we need to do to make the human system more resilient, to endure space for longer periods of time, and these kind of things. But I think there's something even more important to talk about when you think about resiliency, and that is making sure that we have the mandate, a mandate that is bipartisan, apolitical, international, to go do these things for which, if we didn't have the collaboration that we have right now, we wouldn't be able to achieve. So the way I think about it, I like to refer back to history and say what has worked in the past and what has not worked in the past. We have in history, we have the vision for space exploration, which of course was a return to the moon and on to Mars. It resulted in the Constellation program, which ultimately got canceled. And we, with bipartisan members of the House and the Senate, were able to preserve some of that program, a good chunk of that program. But even before that, we had the Space Exploration Initiative, which again was a return to the moon and then on to Mars. And it took too long, it cost too much money, and that got canceled. So we've got examples of what doesn't work. And now the question is, what does work? We look at the International Space Station, which next month we're celebrating 20 years of American astronauts and Russian cosmonauts living and working together on the International Space Station for 20 years. In fact, it's not even next month. It's this weekend, which is going to be a great day and a huge milestone when it comes to space exploration. So I think learning the lessons of the past, what can we apply today? When we build the consensus necessary to have a sustainable program, one thing that we've been working on is, and it's a very simple theme, we've been pushing it everywhere we can at NASA, and that theme is wherever there is division, eliminate it. When I was in the House of Representatives, I was a little bit dismayed when I first got there. I was on the science committee, and it was weird because Republicans were for going to the moon and Democrats were for going to Mars. And so there was a political divide over the destination, which was problematic. There was a divide over, Republicans were for human exploration and operations, and Democrats were for the Science Mission Directorate, which of course is largely robotic in nature. So again, here's a divide where people are putting themselves into teams and then deciding that they're going to fund or not fund based on these priorities. I would like to say these are false divisions. We need to think in a unifying way. How do we bring the Human Exploration and Operations Mission Directorate and the Science Mission Directorate together so that both elements can do more than if they were working separately? How do we bring the moon community together with the Mars community so that both communities can do more when we operate together? And there are other divisions. We've seen, some people are for the traditional ways of contracting for doing NASA's work, and other people are for, contracting in new and unique ways. And that divides people. And then all of a sudden you're either on one side or the other. And if you're not on the right side, then we're not going to support you. These are false divisions. Our goal is to explore space, to get more science, more exploration, more discovery than we could otherwise get. And when we get into these divisive kind of challenges, it tears people apart, and it prevents us from going places. We haven't been to the moon since 1972. That's a problem. And that's not because we have technological, limitations. It's because of the political challenges that we've had. So we're trying to move forward, by removing divisions wherever they exist. So we think about how do we remove those divisions? Well, when we go to the moon, this time when we go to the moon, we're going to go with all of NASA, and that includes the Science Mission Director. There was a time when the Science Mission Directorate of NASA was not going to the moon. The moon was the purview of human exploration, and everything beyond the moon was the purview of the Science Mission Directorate. Well, we need to break that narrative. There's so much science to do at the moon, especially if you're going to have humans there. There's even more science that we can do. So we think about what is the value of the moon from a scientific perspective, and I can go into that quickly. You know, the moon is a repository of data and information from the early sun, because all of those subatomic charged particles that have been coming from the sun for billions of years, they are today on the moon right where they were billions of years ago. That means we can study the regolith of the moon and get lots of data and information about what the early solar system was like, what the early sun was like. But it's not just the early sun, it's also asteroid impacts from billions of years ago on the moon that could be in large deposits, which could give us great insight into the history of the solar system. You know, on Earth, we have this active geology and an active hydrosphere and atmosphere. And so anything that impacted the moon or the Earth billions of years ago isn't today where it was billions. In fact, it's very trace. We call them rare earth metals because when you find them, they are in very trace amounts. Well, the moon could be very different. We could actually learn a lot about the sun and the early solar system by going to the moon. But the moon is also about earth science. So when we think about, you know, the discoveries that have been made just in the last month and the announcements that have been made, where number one, we have found rust on the moon, which means there's oxygen on the moon. How in the world did we get oxygen to the moon? And then we made another discovery. At NASA, the canisters of lunar samples from the Apollo era were opened recently, and we applied new technology to those samples. And what we found is that they're polarized. And in fact, there was a magnetosphere at the moon, a strong magnetosphere. In fact, it looks as though the magnetosphere of the moon's ancient past is stronger than the magnetosphere of the Earth. And the moon and the Earth were much closer together. So our magnetic field lines actually connected, and elements traveled from one body to the other. And that's an amazing discovery, that the atmosphere of the Earth would have been protected by the magnetosphere of the moon, and that elements of the Earth would have been able to travel along those magnetic field lines, which very well could explain another recent discovery, which of course is the fact that there's more water on the moon than we previously ever imagined, not only at the poles, but also at the sunlit regions. So there is so much yet to discover. That water, how did it get there? Where, you know, was it interaction from, you know, these ions coming from the sun? Maybe it was, maybe they're from asteroid impacts. We don't know, but we know there's more water there than we previously understood. So that's another amazing discovery. So we think about the earth science that we get by going to the moon. You know, we know that maybe, I guess nobody really knows because none of us were there, but the scientists are all saying, look, the Earth and the moon were at one time one body called the proto-Earth. It got torn apart, something impacted it, and then it resulted in an Earth and a moon. And the moon in those days actually had a very strong magnetosphere. So I guess the point is, the moon is about Earth science. The moon is about heliophysics. The moon is about planetary science, because why are we going to the moon? We're going to the moon to live and work, learn how to live and work on another world for long periods of time, so we can take all of that knowledge with us onto Mars. So we think about the moon as a tool of planetary science and discovery. It's also a tool of astrophysics. So when we think about the far side of the moon, where it's very quiet from an electromagnetic spectrum perspective, what does that mean? That means we can put a wire antenna on the far side of the moon to collect very low frequency signals that in the universe's ancient past, those signals would have been light energy, but now they're very low frequency radio signals. We can pick them up and we can make assessments as to the early universe. But even beyond that, we could put optical telescopes on the moon. And because the moon is so stable compared to any platform we could put into orbit around the Earth, the moon is so stable that we could actually see when a planet orbits a star around a deep, star deep in our galaxy, we're able to measure the flickers of light every time that planet eclipses that star. And if we can have a very stable platform, we can see those eclipses even more precisely, which means we're going to be able to detect a lot more planets around all of these other stars. In other words, we can get more, exoplanets. We can register more exoplanets, and then we can use the James Webb Space Telescope to train on those exoplanets and make assessments as to what those atmospheres of those planets look like. So my point is this: when we do human exploration to the moon, it's going to enable so much science, and it's going to touch every part of the Science Mission Directorate. I've got one more thing that I think is important, and that is the DAPPER mission, which I'm a big advocate of. The DAPPER mission is a mission that from the far side of the moon, we're going to see not just the first light in the universe after the Big Bang, cosmic dawn. We're going to be able to see the dark ages, which is the period of time after the Big Bang and before cosmic dawn. And those dark ages are going to be available to be seen only from the far side of the moon because it's so quiet from an electromagnetic spectrum perspective. So when we think about the moon, it brings everything together. It's heliophysics, which is part of the Science Mission Directorate. It's astrophysics, which is part of the Science Mission Directorate. It's earth science, which is part of the Science Mission Directorate. And it's it's planetary science, because we're learning how to go to Mars. So it's all of the above. So what have we done to try to break down these stovepipes and in fact create this transdisciplinary kind of agency where we can all work together and achieve more? Well, one of the first things I did as a NASA administrator is we went to the Science Mission Directorate and said, look, we need instruments on the moon. This isn't just about human spaceflight. We need instruments on the moon, and we need to get them there quickly. We need projects like Viper on the moon, which of course is going to assess the water ice and characterize it and drill and do all those things, so that when humans get there, the humans are going to know, where we need to land and what we need to be doing once we get to the surface of the moon. But we need the Prime 1 mission, which is also another water ice mission. We need these precursor missions going to the moon as quickly as possible, led by science. And so the Science Mission Directorate stood up the Commercial Lunar Payload Services Program, CLPS, which of course now we have a number of great contractors that have signed up for IDIQ kind of contracts to take our payloads to the surface of the moon. So you've got the Science Mission Directorate working to help the Human Exploration and Operations Mission Directorate with some of these precursor missions. And in fact, when we go to the moon on Artemis 3, we actually have the Science Mission Directorate right now doing an assessment that they got from academia and industry and research institutes. What is the science we want our Human Explorations Mission Directorate? What is the science we want them doing on the surface of the moon? What is the most valuable science that we can get for the dollar from that Artemis 3 mission? So the Science Mission Directorate is deeply involved in the Human Exploration and Operations Mission Directorate. Once again, bringing the communities together. It used to be that, when I was in the House, people would say, well, every dollar you spend on human exploration is a dollar you're not spending on science. That is not true, and we need to unwind that narrative. It is not a zero-sum game. It's a synergistic game where both can do more when we work together. So we're working on that. We think about the Gateway, which we're going to put in orbit around the moon, and how the Gateway is going to have Science Mission Directorate components as well. We're going to have heliophysics instruments on the Gateway, so we can understand, what the radiation environment is in deep space there around the moon, mainly because we want to protect our astronauts. But the amount of science we're going to get from that is going to be stunning. So when we think about trying to break down the stovepipes, when we think about trying to create a transdisciplinary organization, bring people together so that everybody knows we can all do more when we work together, that's the objective that we're working on every day at NASA. And we're having a lot of success. Look, right now, NASA's budget is the highest it's ever been in nominal dollars. There's a lot of people that have worked really hard to achieve that outcome. We have, for the first time since 1972, we have a human landing system funded. And in fact, we have 3 human landing systems under contract for development right now. So these are big, they're big achievements that I want to be clear that it's a lot of work to get these things done. And in fact, right now, when we think about 2021, The House appropriators have already passed their appropriations bill for commerce, justice, science, and in that appropriation bill, they had $600 million for a human landing system. Now, it wasn't the $3.3 billion that we asked for, but $600 million with bipartisan consensus saying, hey, it is time for the United States of America to lead a coalition of nations back to the moon for a sustainable return. So these are the apolitical bipartisan consensus agenda items that we need to be able to achieve. Then we think about, it's not just the human landing system, but we think about Artemis in general and all of the interest from our countries around the world that have been partners with us on the ISS and beyond. We obviously recently announced the Artemis Accords. 8 nations have signed on to the Artemis Accords. Just yesterday, I signed the Memorandum of Understanding with the United States and Europe for the Gateway, which is another critical milestone. This is not a zero-sum game. Both entities, the United States and the European Space Agency, we can all accomplish more when we work together, and that's what we intend to do. And what you've seen from the European Space Agency, their budget is going up. They have the highest budget that they've ever had because they know that this is a mission they want to be a part of. And in fact, JAXA, the Japanese Space Agency, they just put forward a 50% increase in their budget as a request, which is, again, monumental, a 50% increase in their budget in 1 year, which, again, that demonstrates their commitment to Artemis, their commitment to this long-term sustained exploration of the moon with a purpose of getting to Mars. So these are the agenda items that we are pushing on every day at NASA to build the consensus necessary to actually achieve the outcomes that we all hope to achieve. So with that, I just want to say it's great to be here at the Von Braun Symposium, and I'll look forward to answering questions.
All right, Jim, thank you so much. We do have a couple of questions that came in, and one is, talks to what you were just talking about with the MOU that was just signed. And so this is from Jeff Faust. You announced yesterday that MOU. So what is the status of similar MOUs with CSA and JAXA? Have there been discussions with Roscosmos? Especially keeping in mind the comments at the IAC. So I'll let you go on that.
Yeah. Yes. So we have been in talks with every nation or every entity that is part of the International Space Station. So when we think about how we're doing the Gateway MOUs, it is based on the intergovernmental agreement from the International Space Station. So the partners that are with us on the International Space Station, of course, will be with us on the Gateway. And of course, we do believe, and in fact, would like to even expand from there. But at this point, I don't have anything to announce as far as those negotiations and MOU signings. I will tell you this, Jeff Faust, stay tuned because we're getting close.
Gotcha, great, thank you. And so this question's a little more forward-looking, which is what we've been doing a lot of at the Von Braun over the past 3 days. This comes from Sarah Roman. Once we've reached Moon and Mars, and we've got sustainable, structures and research going on, what's next? What do you imagine is the next big initiative after that? After
Moon and Mars.
Yeah. So
okay.
Put on your binoculars, look way out there.
Yeah, no kidding. Let's sustain human life on Pluto. Can we do that? I say that in jest, but
whether
only
it's a planet or not.
No, it is a planet. Make no mistake. I am committed to the fact that Pluto is a planet. Look, a couple of things I think that are important. Number one, we need to continue developing space. So right now in low Earth orbit, we're trying to make sure that we don't have a gap when the space station ends and when we move to commercial space stations. We need appropriations for that. I mean, that's the biggest, number one, highest priority. I make no mistake, we've got a lot of priorities. So I don't know if I should say that's the number one highest priority. We've got a lot of priorities, but we have to make sure that we have a continuous American human presence in low Earth orbit. Because if we have a gap there, there will be other countries that step into that role, and all of a sudden we could lose a lot of our leadership, a lot of our prestige, our international partners could go to other countries. We need to make sure that we are the nation that leads the world in space, and that requires investment into the next space stations. And I say space stations because I want to see multiple commercial space stations, just like what we've done with commercial resupply, commercial crew. We need to have commercial space stations. So the development of space, the utilization of microgravity to improve human lives here on Earth, I think those are the big things that we need to be thinking about. But also living and working on the moon, we're going to learn a lot about what we can do on the moon that we might not even be able to do in the microgravity of low Earth orbit. And then of course the discoveries from Mars. Every day we're getting new discoveries and indicators that there could be life on another world, namely Mars. And I think it's important that we go search for that. This morning I was in a town hall with Senator Capito from West Virginia and a lot of her students in school. And one of our astronauts, Laurel O'Hara, joined us, and she was a marine biologist before coming to NASA, and she was showing us images of life at the very bottom of the ocean. And this is life that is not dependent on photosynthesis, not dependent on light at all, which is very unique. And so when we think about the fact that that kind of life can exist at the bottom of an ocean, it makes you wonder about places like Io, or places which I know Io is not an ocean world, but Enceladus or Europa. I mean, these are places that we need to get to in order to make the discoveries that I think are important for us as a nation to make.
Right. So this one's from our friend Keith Cowing. NASA announced the presence of water on sunlit portions of the moon, and that goes into ISRU, resource utilization. So what's NASA doing to increase the focus on that, with these discoveries and sustainability and what we're doing on the surface?
Absolutely, and Keith is right on. We need to be putting a focus on that. One of the things we did recently is we announced the Lunar Surface Innovation Initiative, and then we turned that into the Lunar Surface Innovation Consortium. So we've got a consortium of research institutes, universities, and even industry that have come together now to help us figure out how we're going to use the resources of the moon. And the goal here is to bring innovation in from outside of NASA, and things like surface power. We're going to need to separate the water ice from the regolith. We're going to need to crack the water ice into hydrogen and oxygen, and then turn it into something that's usable. So we need surface power. We need a grid system. We need habitation capability. We need transportation capability. We need to be able to mitigate dust. These are all important technologies that need to be developed, and NASA may or may not have all of the answers. So bringing in the outside, letting them tell us what they think would be the best course of action, and then we be able to vet that. So we're reaching out to the research community for those kind of innovative ideas.
Gotcha. And we're just about out of time here. We've got maybe 30 seconds left. So two kind of lightning quick questions for you, if you would. So in your time as an administrator so far, what, how confident are you that what you've built as far as a bipartisan, coalition, how long will that endure? How confident are you in that?
So I think we're in good shape. Again, it's not me. It's got to be driven by Congress, and it's got to be driven by people that come after me. But really, it's got to be driven by the American people. That's one of the reasons I love the Artemis name. We love the Apollo generation, But with Artemis, we're going to the moon with this very diverse, highly qualified astronaut corps. We named the program after the twin sister of Apollo. I think America is, I mean, I was just recently looking at polling, and America is behind sending the first woman to the moon under the Artemis program. Now, it's not got 100% ID at this point. We need to keep working on that, but the people who are familiar with it are all supportive of it. So that's a very, very positive kind of development. We haven't had that level of enthusiasm from the American public in a long time. But I would also say that it's important to remember that that we've been through troubling times in the past, and we need to learn from that. Those are opportunities to learn and figure out how to not repeat those problems. And I think we as an agency have applied that, and I think Congress knows it too. I mean, everybody saw what happened when the Constellation program got canceled, and we were not shut down, but there was a period of like 2 years where nobody knew what the mission was and where we were going and what we were doing. Congress doesn't want that. When I was in Congress, we passed a bipartisan NASA Transition Authorization Act, basically saying, look, don't change anything. Like, just keep moving forward. So those are the kind of things where I have confidence that we're going to continue to have the bipartisan support that we need.
Great. Yeah, I think the American public definitely wants to keep the wind in the sails, keep it moving, solar sail, whatever kind of sail you want. All right. And executive privilege, my one question that I have to just about everybody, and seriously, 20-second answer. What's keeping you up at night?
You know, I don't have 20-second answers. I mean, seriously.
I'm trying.
No, look, I think our agency is doing amazing things. I'll tell you what keeps me up. We got Crew 1 coming up. We're 3 weeks away from launching American astronauts again. I'll tell you, I love our astronauts. They have ice in their veins. They at least don't present any kind of nerves to me or anything, but I'll tell you, it makes me nervous, and I want that mission to go as successfully and as smoothly as DM2 went. And I'm confident that it will. We've got the green run coming up with the SLS rocket. We've got some great things happening there. We've got some challenges to overcome. We've got a hurricane that's bearing down on Stennis right now. But there's great people there doing great work. And here's the thing: we're doing all of these things that are stunning, whether it's DM2 or Perseverance or Bennu with OSIRIS-REx. We're doing these things, and now we're doing Crew 1 and the Green Run. We're doing these things in the midst of the pandemic, and the American people are proud of the work that NASA has been doing, and the workforce at NASA has just been so diligent about being safe, about continuing with the missions that are essential for the country. There's a lot to keep the NASA administrator up, but the workforce at NASA is just really unbelievable, and I'm so grateful to all of them. So I want to say thank you to the American Astronautical Society for hosting this. I want to thank the Von Braun Symposium for inviting me, and of course Lockheed Martin. And another final big congratulations to the Lockheed Martin University of Arizona team on OSIRIS-REx. Couldn't have gone any better, and we're so thrilled that that was it was a bright light in the middle of a difficult year.
You bet. Excellent. Well, thank you so much. We really appreciate it. Great talk. Thank you so much, and we'll see you again soon. All right. Take care. And